Hey everyone, welcome back to the channel. This is Rob, and in today's video I'm going to show you how to configure active standby failover on two ASA firewalls. If you look at the topology over here, you will see the two ASAs, and they're connected together using the management and gig 0/3 interface. The reason I'm using the management interface is because in a smaller deployment, you typically won't be using the management interface. I mean, maybe you will, and if that's the case, you would want to choose a different interface for the primary failover link. But if you're not, like we're not going to be using the management interface for management in this lab, I chose to use it for the primary failover link. So management 0/0 will be primary failover, and then gig 0/3 will be for the stateful failover. So the transferring of states between the two firewalls. So firewall states, as well as if you're performing network address translation on your firewall as well. The rest of the topology is very simple. We have two switches. We have an inside switch for all LAN devices and an outside switch, which is connecting to the internet. This is all layer 2 to the ASAs. So that means if you connect a host to this switch right here on the inside, routing happens starting at the ASAs. So no VLANs or SVIs on the switch. These are not layer 3 links. It's all just layer 2. Same thing with the outside switch as well. So with that being said, I'm going to show you the physical equipment, since I'm doing this on actual ASAs, and I will leave this diagram up throughout the video as well for reference. So when I am configuring an interface, you will be able to see what interface that is actually connecting. So here's the physical equipment. You will see that there are two ASA firewalls right here, and the management interface on both is what is connecting them together, just like what was shown in the diagram. So this will be for the primary failover link. Gig 3 will be for stateful failover. And then these links right here connect to the inside and outside switches. So gig 1 on both ASAs comes down here to the outside switch on fast Ethernet 1 and 2. Gig 0 on both of the ASAs connect to the inside switch, and this will be the switch that I will connect a PC to at the end of the lab to show you that we do in fact have internet connectivity, and I will also do a test failover from ASA 1 to ASA 2 to show you the redundancy. We have a console cable right here, and that's just connected to the laptop that I will be doing this tutorial on. Let's hop over to the computer and I will show you how to configure this. Okay, so I'm currently sitting on ASA 1, and so we want to go into privilege exec mode and then configuration terminal. So now that we're in global config, we can start issuing the commands to enable active standby failover. So I start with failover LAN unit primary, since ASA 1 is going to be the primary ASA. And then failover LAN. Now what this is going to do is this is going to tell the ASA what interface will be the primary failover interface. So as you see, that is management 0. So we'll say failover LAN interface, and then we give it a name. So anybody familiar with Cisco iOS, like on Cisco ASA routers and whatnot, ASAs are a little bit different. Some of the commands are kind of backwards. Some of them are completely different altogether. And then certain things like this are completely different because you specify a name for the interface instead of just saying, hey, failover LAN interface, you know, whatever. So we are going to specify the interface, but we do need to give it a name first. So I'm going to keep it real simple here and just name it failover. Honestly, I don't know really what else you would name it, but I feel like failover is fitting. So we'll say failover LAN interface failover, and then now we specify the physical interface. So that will be management 0/0. So this just tells us right here that non-failover interface config is cleared, and if there were any sub-interfaces on that interface as well, that was cleared also. Next, we will say failover link. Now, this is where we configure the stateful failover link. So, first command, failover LAN interface for the primary failover link, and then for the stateful, we will say failover link, and then we'll give it a name. So we will say stateful. If I can spell, so failover link stateful, and then we say what the physical interface will be. So that will be gig 0/3. Okay. Now the next step is to assign IP addresses on these interfaces. So first they have to be running IP in order to function. The way you enable IP on an interface is you assign it an IP address. So we're not actually going to go under the interface like most of you are probably familiar with, unless you're used to working with ASAs. In normal cases, you would go under the interface, but for the failover configuration, we're going to configure the IP address through the failover command. So we need an IP address on the interface, so management 0/0 that we named failover, and interface gig 0/3 that we named stateful. And the way we accomplish that is by saying failover interface IP, and then failover, and then we give it an IP address. So we will say 172.16.1.1, and we will give it a /30 subnet mask, since we only need 2 usable addresses, one for the one address on the active ASA and then one on the standby. So failover interface IP, and then failover, we'll say 172.16.1.1 with a /30 mask, and then for standby. So the standby address is what, so on this interface right now, because we designated management 0/0 as the primary failover, when ASA 1 is active, it will have the IP address 172.16.1.1. ASA 2 being in standby, or when it is in standby, it will have the IP address, we're going to say 172.16.1.2. And then that will flip if they switch roles. So if there's a link failure over here or something and ASA 2 becomes active, ASA 2 will have the IP address on the management interface 172.16.1.1, and then over here 172.16.1.2. So for standby, we'll say 172.16.1.2. And last but not least, well actually not last, because after we're all done with this, we do need to issue the failover command to initiate failover, or to tell the ASAs that we actually want to be in active standby. So we will go, let's see, yep, failover interface, and looks like my camera died, but I guess that's okay. I don't think anybody watching this is too concerned about seeing my face anyways. So failover interface IP, and then stateful, and we'll say 172.16.2.1 with a /30 mask, so 255.255.255.252, and then standby 172.16.2.2. Okay, and we are almost done. If we were to issue the failover command right now, if the other ASA was configured, then we would be all set. But I'm going to wait until we configure ASA 2, and then I will issue the failover command on both. So let me go ahead and switch this console cable over. And here we are on ASA 2. So privilege exec mode, and global config. Same commands as we issued on the primary ASA, except with some slight differences. So we'll say failover LAN unit secondary instead of primary. Failover LAN interface failover, and that will be management 0/0. Failover link stateful. I keep missing that T. Hey, failover link stateful gig 0/3. And then failover interface IP failover 172.16.1.1. This will be the same as on ASA 1. Failover interface IP stateful .2 16 2.1. All right. And I forgot to bring the interfaces up. So let's do that really quick. Let's go interface management 0/0, no shutdown, interface gig 0/3, no shutdown. We'll switch back over to ASA 1, do a no shutdown on those interfaces over here as well. Okay, so now we have configured everything necessary for active standby failover on both ASAs. Now it's time to issue the failover command. So we'll say failover right here on ASA 1, and we'll move over to ASA 2 and issue the same command. Now, before I started this, I meant to make sure that both ASAs were running the same version. The primary has the image contained in its flash. However, it wants to boot off of the 8.4. So this is still going to work, but in the real world, I highly recommend that both firewalls are running identical software. So just keep that in mind. Okay, so it says here we detected an active mate, and the ASAs are beginning the configuration replication. And if you'll notice that this prompt switched to ASA 5520-1. So they are both considered to be the same now. The only thing is that you can't configure anything on the secondary. So if we were to look at the ASAs right now, we would see that one has a green light for active, the other one has an amber light for active, meaning that it's secondary, but that's not much of a help when you are not standing right in front of the rack. So let me switch the console cable back over to ASA 1, and I'll show you how to give yourself a visual way to tell which one's active and which one's standby. So in global config mode, we can issue the prompt host name. Now, if we use the context-sensitive help, we'll see that we can go context, domain, priority, state. We're not using contexts, so we will just use the state and the priority. And once we issue that command, we'll see that we have the host name, we see that we're active, and primary. Let's move over to ASA 2. And do you see that we don't need to enter that command on ASA 2, because now that they are an active standby failover pair, it automatically applied that to the second ASA. So we see that on the second one we're standby and it is secondary. Hey, so if you came here to watch this video just trying to figure out how you would set up ASA firewalls and active standby failover, you can pretty much end the video here. That's all there is to it for a basic configuration. For anybody else that's still curious about some things, I'm going to configure the rest of this and get this working with internet, and I'm going to connect this computer to the inside switch, make sure we have internet, and then actually test a failover. So that's also going to include me configuring NAT on the ASAs as well. So let me switch back over to ASA 1. And I'm going to start with the outside interface and then move over to the inside. So this outside interface is actually on the 10.0.14.0/24 subnet on my internal network. So that is the subnet that I need to assign an IP within that range on gig 0/1 for this. And then for the inside, I can pretty much just whatever it is that I want, since we will be doing NAT on the ASAs. So from here on out, I don't need to worry about switching over to ASA 2 because everything I configure here on ASA 1 will be replicated over to ASA 2. So let's start with that outside interface. So we'll go interface gig 0/1. We'll do a no shutdown. We'll say name interface outside. That should automatically set the security level, and it did. So it was set to 0 by default. We'll say IP address 10.0.14.200/24 mask. Oh, and then what I mentioned before when we were configuring failover at the standby IP, if you see I got a warning here that says failover is enabled, but standby IP address is not configured for this interface. So the same thing would apply. So say that I said, IP address 10.0.14.200, and then standby 10.0.14.201, that would mean that ASA 2, while it's in standby, would actually have the IP address 10.0.14.201 on its gig 0/1 interface. So that way you can you can connect to the ASA when it's in standby. You can manage it, and that sort of thing. So I'm actually not going to worry about the standby IP address right now, but just know that that is something that you can configure. Okay, before I move forward, I'm going to ping the gateway and make sure that I have reachability. Okay, and I do. So with that being said, I can configure my routing. So I'm going to say route outside, quad 0, 10.0.14.1. Let's try to ping an internet address. Okay, so the ASA now has internet connectivity. And now I'm going to move to configure the inside interface. So we'll go to gig 0/0, no shutdown, name interface, inside. Oops. I accidentally, I'm so used to pressing tab to complete commands, but that's not one that it will do by default. So we don't want the security level to be 0 by default. So since it thought that I typed in INS and it doesn't know what that is, it set it to 0 by default. So we will say security 100, which should be the default if we would have typed in inside to begin with. Okay, and then we'll just say IP address, we'll use class C, so 192.168.1.1/24. Okay, and again, we didn't configure a standby address, so that's what this warning is here for. Okay, so let's configure NAT and give this a test. Object network NAT, and then for subnet, quad 0, and then NAT, inside, outside, dynamic interface. Okay, show route. Okay, static to 10.0.14.1. Okay, so let me connect this computer to the inside switch. So I will connect it to this switch right here, and we should have internet. And then I will perform a failover from ASA 1 over to ASA 2. So let me just grab a cable and plug this in. And of course, that just took down the GNS3 topology, since I'm connected to that server remotely. Okay, and so since I didn't set up DHCP, I'm going to have to go in here and configure this statically. So I'll say 192.168.1.10, 192.168.1.1, and then I'll just do 1.1.1.1, 8.8.8.8 for the two DNS servers. Ping 192.168.1.1. So we can ping the ASA. I don't think we will be able to ping out though, because the ASA blocks ICMP echoes by default. So we need to do is configure the ASA to inspect ICMP echoes. So that is accomplished by changing this global, this default global policy. Let's copy and paste here to make it easier. Inspect ICMP. Now we should be able to reach out. Okay, and then let's make sure NAT is working. So we'll go show translate, and we have some translations here. So we see that our computer that we just configured for 192.168.1.10, we have multiple NAT translations. So, okay, so we have internet. Let me actually open up a browser window, and let's go to google.com and type in test. So we have internet. So we saw the, actually I was pinging on the screen that I'm not doing the screen record on, so let's do that one more time. So we're pinging out to the internet there, pinging 8.8.8.8, ping Google. And at this point, I think I'm going to switch over to the other camera so I can show you the physical equipment while I pull the link and then show you the switch over from ASA 1 to ASA 2. So with that being said, I'm also going to run a constant ping so we can kind of see the delay in between as well. Okay, so let's switch over here to the physical equipment, and I am going to pull one of these links and switch it over to ASA 2. So we will pretend that the inside switch, the primary link to ASA 1 failed. So I'll do that just by pulling that out. And if you look at these lights right here, you should see the ASA switch over. And now you see that this one went amber and then this one is green. If we come back over here, it looks like we dropped one ICMP echo. And we should still have complete internet connectivity. All right, so that pretty much sums it up. We configured the two ASAs in active standby failover, tested that failover would work correctly, which it did, so that's definitely a good thing. With that being said, I really hope you learned something from this video. I hope it was a help if you were looking to learn how to set this type of thing up. If you do have any questions or anything like that, feel free to leave a comment in the comment section below. You can email me directly. My email is rob@rmtechcentral.com, and I'd be more than happy to help. So thanks for watching, and I'll see you in the next video.